Hey there, ladies and gentlemen. Here we go, topic 2.4, the last one from topic 2. So there'll be a quiz coming after this. It'll cover topic 2.1, 2.2, and 2.4. So no pressure. Just make sure you guys watch the videos and should be a-okay. This is kind of an important section. There's only a few slides, but it might be a little bit long just for me to explain it. There'll definitely be some quiz questions on here. So make sure you guys pay close attention, especially when we talk about climate. Okay? So let's start with a little bit of a comparison here. What do we notice about Nanaimo? Some of you may have heard of Nanaimo. It is on Victoria Island. I've got family that live out there. And what do you notice about Lethbridge? Right over here. Okay, so just a little bit north of us. Anyone? Some of you are saying, oh, well, they both are cities in Canada, which is true. But we take a look at how far their latitude right here, right along here, they are at about the same elevation or the same distance from the equator, which would be way down here. Okay, so here's two beautiful pictures we have from our textbook. Okay, picture above is Nanaimo, and the picture below is Lethbridge. Very quickly, this is where we'd have a nice little classroom discussion. What do we notice about these two pictures? What differences do you notice? So I am going to be you. I'm going to put up my hand and say, oh, Mr. Button, I know, I know. This one right here has nice, pretty flowers. Okay, there's flowers blooming. The trees are all nice and green. Right here, we got a little bit of algal growth out on the water. Okay, there's water. It's all wet. There's no ice. Just beautiful. I'd love to be there right now. Then what do we notice down here? Well, the trees, they are all bare. Okay, there's people rollerblading. Okay, they all have hats on, no jackets, but they all have jeans. So it's not short weather, but it's okay for short sleeve weather. Okay, so when do you think these pictures were taken? Okay, what month do you think the picture above was taken? And what month do you think the picture below was taken? Well, I'm going to go and volunteer. I'm going to go and say, oh, this one was probably taken in the springtime. And this one was probably taken in the fall, Mr. Podman. That's what I think because the leaves are bare, and up here the leaves are all nice and green. This might even be late summer or like early summer because everything is all beautiful and lush. And then I go and say, the picture taken in Nanaimo, that one right here was taken in March. Okay, so actually it would have been like 2 months ago, back when this whole COVID-19 thing started. Excuse me. So yeah, like back in March, this picture was taken. So 2 months ago, when we were getting snowstorms, when we were getting a lot of cold weather, Nanaimo was getting nice, pretty flowers and leaves on the trees. When was the picture in Lethbridge taken? Da, 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 da. There used to be a typo in here. Hopefully, I changed it. It was taken in April, a month after this picture was taken. This picture was taken. Okay, so about a month ago, this is what it looked like out here. Okay, now we're in May, we're in late May. The trees have leaves on them. Some of them, the leaves are starting to come. But down here, about a month ago, nothing. So why do we think there was such a difference? Big hint is the topic is water and climate. So the difference is because of climate. So here's the first definition. Climate is the average weather measured over a long period of time. Okay, it's very important that we know it's the average. It's very different than just the weather. What's the weather outside right now? It's raining, right? In order to determine our climate, we would have to take the average weather of every single, today is March 21st, I think it is. We'd have to sorry, May 21st. We would have to take the weather of every single May 21st over a long period of time, and that's how we can come up with our climate. Okay, even though both Lethbridge and Nanaimo may have the same amount of sun and temperature, because we showed that first picture, they're about the same distance from the equator, so they have the same amount of sunlight, and the sunlight beats down, so it gives it the same amount of temperature over the whole year. They have different climates. Okay, Nanaimo, maybe a little rainy and whatnot, but typically not as cold as what we have. Longer, greener seasons than we have. It's a lot more dry. It's a lot drier, and we have a lot more colder seasons. So why do you think this is? I already talked about it. It's large water bodies. What's the large water body that's Nanaimo is around? Well, it's close to the Pacific Ocean, right? So there's a lot of water around Nanaimo. It's on Vancouver Island, which is actually separate from all of the land, and it's in the actual ocean. It's an island on the ocean, very close to land, but still it's an island on its own. Whereas out here, Lethbridge, it's kind of landlocked, kind of like Airdrie, landlocked. Sure, there's lakes and ponds and things around, but it's not a huge, large water body. And we're going to be doing a little bit of rewinding going back to grade 7 here. So last year you learned that water has a higher heat capacity than most other substances. Okay, so if you remember what that means it can hold on to heat longer than other substances. So the water itself actually holds on to the heat longer than the ground does, for example. Okay, on the same token, it also takes longer for the water to heat up. Okay, so if you have the same amount of sunlight shining on down on the water and the land's going to get hotter a lot faster than the water will. However, once the sun goes under, the land will lose its heat a lot faster than the water will. And I usually have a nice little analogy here where I embarrass some kids and I say, think about the beach. When you go out to the beach and you go on a nice hot day, you put that towel down, you're sitting there getting some rays, the sun's beating down on you, and you're like, okay, it's too hot. It's time to get into that water. You go and you step off that towel onto the sand. What happens? You start doing that funky little chicken dance because your toes are burning from the sand. The sand is so hot. And you run, you do that funny little dance. Your parents sit off to the side laughing at you, and you get to the water. As soon as you get to the water, it's like, relief, right? It's not like the cartoons where the water starts sizzling, but you can definitely feel the relief. Now, that same sun, or the sun that's been shining down on the sand, it's been shining down just as long as it has on the water. Why is the sand and the water not the same temperature? That's because of the heat capacity. The sand absorbs the heat a lot faster than the water does, but the sand actually loses the heat a lot faster. So go bring us back to that same scenario. You're out on the beach and the clouds come in, right? And the clouds start covering up the sun, right? So you're out in the water, gets a little gloomy. What starts happening? You start shaking, right? You start feeling cold because the sun's gone behind the clouds, or the clouds have gone in front of the sun. So it's time to go run back to your beach towel and get a towel on or put on some more clothes. You run out there. Do you worry about the sand? You don't. You run, and almost instantly, as soon as the clouds go cover up the sun, the sand itself loses its heat. You're not burning your toes anymore on the sand like you were when the sun was beating down. Okay, so it takes a long time for a large body of water like the ocean to heat up. So obviously, the larger the body of water, the longer it takes. Thus, it takes a longer time also for that large body to cool down. Okay, so again, think of the beach versus the water. This explains why the temperature between Nanaimo and why there's temperature differences between Nanaimo and Lethbridge. And you guys all know now, right? Let me explain it. Okay, so Nanaimo is close to the ocean. So yes, when the sun goes down, and it'll go down approximately the same amount of times as it does out here. When the sun goes down, okay, the land starts losing its heat. Okay, and that's normal. The land starts losing the heat. However, we've got this big body of water, okay, big body of water surrounding Nanaimo that is holding on to the heat. So the heat obviously is going from the water up into the air because heat always moves from hot to cold. So that heat moves up and starts getting the air around it hot. Okay, as the heat starts moving up, it gets pushed one of two directions, right? If it's going out this way where there's more water, well, it's just going to be all heat. It's going to want to move in this way because the air above the land is now cool. So that heat is going to move up and move towards the cooler areas because remember, heat always moves from hot to cold. So it's cold over top of the land. So the hot air from the water is going to want to move and go towards that warm land area. So that is why there's a big difference between day and night temperatures out here. We don't have those big water bodies out here in Alberta, the Airdrie, Lethbridge. So once the sun goes down, the ground itself loses its heat really quickly, and there's no heat that comes in to replace it. Lethbridge has few lakes surrounded by land. The land heats up and cools down quickly. This is why there's big temperature differences. This is important. Remember this slide. Find it on D2L if you want, or else pause it here and make sure you have this slide for your quiz because I'm pretty sure there's going to be quiz questions on this. Next we go, what about the mountains? Okay, do the mountains have any effect? Okay, And of course they do. Over here, somewhere over here would be Lethbridge. Over here would be Nanaimo. What happens over here? Over here, we have those nice moist winds, but up in the mountains, it's really, really cold, okay? And then back over here, we end up by getting the dry Chinook winds. Why does that happen? So the air above the ocean, that's obviously it's warm. We've already talked about how the air above the ocean is warm, but it's also moist because as it's moving up, it's carrying water vapor up with it, okay? And it always wants to go from hot to cold, so it's going to be moving our way, okay, towards the east because it wants to go and replace the cool air. So as it moves, it needs to hit these mountains. So it moves up over top of these mountains, but it's really, really cold. What happens? Think of the water cycle. What happens with water vapor as it cools? It condenses. It goes from a gas into a liquid, and it starts to rain. It comes down as precipitation. But that air is moving pretty quick. So it's still fairly warm. So it's moving up over the mountains. It's losing its moisture and it comes down here over the mountains. This is where we get some nice, warm, dry wind, and we call those the Chinooks. Okay, it's new to me. Like I've only been in Airdrie for 10 years, and it was amazing when these Chinooks blew in. The temperature changes almost daily. Okay, so we have warm, moist air from the ocean moving in over the mountains. Okay, and then the moisture in the air condenses and turns into precipitation, falls either as rain or snow. Okay, and then the wind has now lost its moisture, but it's still warm. It's still a nice warm wind. And then it comes into Alberta as Chinook winds. Some of you, we're not going to go into this in too much detail. If you want to have a fun time, try to Google Leonardo DiCaprio back when he was filming the Revenant out here in Alberta, and he said he witnessed global warming because a Chinook blew in, and we had snow one day, and the next day it was all nice and warm, and the snow was all melting. I'm not going to go and say what I feel about global warming. Some of you know, but yeah, Leonardo DiCaprio took a few steps back in the whole global warming movement because a Chinook is perfectly natural. It's been happening for many, many, many years, and it has nothing to do with global warming. It has to do with the way that the air works. Okay, so that deals with us, landlocked, Nanaimo versus a landlocked area. However, there are places in the world, and again, this is a textbook picture, where there are two areas that are at the same elevation. They're at the same distance from the equator, like Labrador and Scotland here, but they have drastically different climates, even though both of them are surrounded by water. Okay, so both Labrador and Scotland, right here and right here, are at approximately the same latitude as well. They're both the same distance from the equator, so they get the same amount, roughly the same amount of sunshine every single day for every single year. But their temperatures are quite different. Okay, Labrador, Canada, very cold winters, short, cold summers, while Scotland has mild climate with very little snow, but both are beside the Atlantic Ocean. Why is this? Well, we've got a bunch of lines in here, and I'm sure if you guys have watched the news, the Weather Network, and whatnot, you may have seen some of these lines. It all has to do with these lines, which are called currents. Okay, so take a look at the currents we have here. I'm just going to go to the next slide. Actually, let's go over and we'll talk about currents first. Currents are actually streams of water that move, that actually move within larger bodies of water. Every single year when I talk to students about currents, I'm like, where have we heard currents before? What do you think about when you hear currents? And they're automatically like, Finding Nemo. Yeah, Finding Nemo. Those surfing turtles, and they go into the East Australian current or whatever it is, and they actually go in they're swimming there, and they're swimming right next to a moving body of water, and then they move into the current, and then boom, they're blasted off to a really far away place. Wow, that's kind of the way it works. Currents are actually streams of water that move in the water, and there's two types of currents. There's surface currents and below surface currents. Okay, currents can be caused by wind, temperature differences in the water, and salinity differences in the water. Okay, and as well the Earth rotation, the spinning of the Earth. Okay, so now how do currents affect temperature? Well, let's take a look at the beautiful picture that I have over here. Okay, we've got currents, and it shows in this picture the direction that these currents are moving? Well, right here we have Labrador, okay? And we have a current called the Labrador Current that's coming from up here, moves down this way, spins over this way, and spins in here. We also have the North Atlantic Current right here that comes from way over here and spins down this way. Okay, so both of these currents move relatively close to Labrador. Then down here, we have the Gulf Stream Current, which moves across this way and goes towards Scotland and then moves up here and around Scotland. Why do you think those two currents would have an effect on the climate and cause this Labrador to have really cold winters and cool summers, and Scotland has mild ones? Okay, and every now and then every year I get a few students that they notice it. They notice the direction of the arrows. The Labrador current and the North Atlantic current are originating from up here, close to the Northwest Territories. Well, what's the weather like up there? It's obviously cold. Okay, so because the weather's up there cold, the water in these currents is cold. It's a colder water in the currents. So as the currents move through the ocean and they come close to Labrador, they're depositing that cold air. They're making the air cool. So the warm air that would be over here would be wanting to move out to the ocean, causing the temperatures to drop. The opposite is true down here. The Gulf Stream, where does it originate? It's coming down from down here. Down here somewhere is the equator. So obviously the water is warmer. So it's moving up here, the current, a big stream of water carrying warm water. Okay, and it comes close to Scotland. So the exact same principle as why the Nanaimo and Lethbridge have different climates and different temperature and whatnot, the same principle occurs here, but it's just because of the currents, not the water bodies themselves. It's the water that's moving within the larger water body. Very important, okay? Very, very important. I teach this again in grade 10. It's important stuff. You need to know this, okay? So currents, we went over this, what they can be caused by. So this is just summarizing. Water and currents actually move. So it's not like the waves, which are just moving in circular motions. The water and currents are actually moving. And remember in the last unit, I said there's actually three ways water moves. Currents was the other one. Surface currents, so little currents that are on the water. And if you've ever actually been on a ferry or something like that, you've probably seen them. You've probably seen the currents. They move by wind. And if they originate in a warm area like the equator, they're carrying warm water, thousands and thousands of kilometers. And that's what happens with Scotland. It's warm water that's being carried over towards Scotland. Okay. The same is true with Labrador. It receives cold currents from the North Pole. Okay. And Scotland receives the warm currents from the equator. Okay, the temperature of the ocean also can affect precipitation, obviously. Okay, since warm air can hold on to more moisture than cold air, wind blowing over warm currents has a tendency to carry that moisture and thus cause more precipitation with condensation and whatnot. But wind blowing over colder areas, they tend to be relatively dry because that precipitation is locked up, it's cold, so there's not as much not as much rain. That's it. I know it was a little bit longer. It is an important section, so please make sure you watch this. Well, hopefully you watch the video. It's at the end of the video, but please make sure you refer back to the video or to your textbook when you do the quiz. Okay, the quiz should not take very long. We're looking most of these quizzes. I'm hoping 15, 20 minutes. They should not be taking 2 minutes. Those of you that have been whipping through and just doing them in 2 minutes, but on the same token, they shouldn't be taking 4 or 5 hours. They should be taking about a good 15 minutes to half an hour. And again, you can always refer to your textbook as well. That's it, boys and girls. Email me if you have any questions. We'll talk to you later.